After introducing specification by example, or BDD, at General Motors, I went and did the same thing for United Technologies, and am now doing the same thing again with a very well-funded startup in Silicon Valley called Turntide. They manufacture high-efficiency electric motors. So all of those companies, I would say, would be delighted to save $50,000 per developer per year. So I have helped at least parts of them learn how to do that. So I'm going to jump in and start talking about that here. And if you have questions while I'm talking, please go ahead and send them in chat. And Sue, if you would keep an eye on the chat, and if it's a question that you feel would be best addressed in the presentation, go ahead and interrupt and ask me. Perfect. And if they say, let's ask this one at the end, why, we can hold it at the end. Thank you. So how can we save $50,000 per developer per year? Well, a typical developer spends 30 to 40% of their time fixing bugs. And if our typical developer with benefits is costing us $150,000 a year, then 30% of their time is $50,000 per developer per year. So it's easy. All we have to do is eliminate the bugs, and we can save $50,000 per developer per year. So let's talk about that. I like to talk about two types of bugs. There are little b bugs, and little b bugs are the ones where the code doesn't do what the developer intended. The comparison is wrong. They allow 21 characters in the field instead of 20, and the last character disappears off the end, or the database field isn't large enough for the data that's supposed to go into it. Those are little b bugs, and they may or may not be difficult to find. They're usually not expensive to fix. Big B bugs. Big B bugs are the ones where the code does exactly what the developer intended. It's just not what the customer wanted. And these can cost you real money. The entire development team may have spent 2 or 3 sprints writing really good, clean, high quality code that they can be proud of, and that you now get to throw away because it doesn't do what the customer wanted. Specification by example, or as it's more commonly known, BDD, behavior-driven development, is a development methodology that is designed and documented to eliminate bugs. So let's see how it does that. Specification by example is a better name for BDD. BDD doesn't tell us what we're doing, but whatever it is we're doing, it's the developers who are doing it. Specification by example says that we are writing requirements and they include examples. And product owners and business analysts write requirements. And that's where this should start. We're also going to talk about TDD, test-driven development. TDD means that the developers are writing unit tests before they write the code, and that's a very good practice. It has a smaller scope and less impact than specification by example. So I well remember how when I went into General Motors and began working with a QA team there, and I told them that we were going to deliver together, we were going to deliver automated tests to the developers while the developers were still writing the code. And these folks all had lots of experience. Their average experience level was probably 15 years. And they looked at me like, you are definitely from Colorado. You are smoking some really good stuff. So let's see what his specification by example has been documented to do. So at BNP Paribas, a very, very large multinational French bank, the developers were spending 30 to 40% of their time fixing bugs. And a consultant named Simon Powers went in and introduced specification by example and TDD. And 9 months later, those same developers were spending 1 to 2% of their time fixing bugs. So notice that's 9 months later. Specification by example isn't magic. It isn't take a 3-day class and become an expert. It takes time. It takes practice and discipline, and it is a whole team methodology. At Vanguard Financial, they introduced specification by example and microservices. They were already agile, had been agile for 5 years. And their IT department is 4,000 people. So it takes time to roll out that large of a change across that large of an organization. They used a train the trainer model. Coaches and trainers would come in and train a couple of teams, and then a couple of people from those teams would go start working with additional teams to bring them up to speed. At the end of 3 years, they had reduced defects across all of IT by 40%. And some teams had essentially eliminated defects. And at the end of 3 years, you would have some teams that had been using SBE for 3 years and some for 3 months. So some of them were really good and some of them were still very much learning. But overall, 40% reduction, and some teams, essentially, they no longer shipped bugs. At United Technologies, later Raytheon Technologies, after they merged, I introduced specification by example in a data science group. And not the first year I was there, but over a 1-year period, the teams I was working with delivered maybe 2 bugs into production. We debated whether we could really call them bugs. At General Motors, I introduced SBE in a QA team. They had been using 8 automation engineers to automate one website. A year later, they were using 1/2 of an automation engineer to do the same job. And they were using 1 manual QA tester to actually run the tests. And instead of delivering the updates 1 release behind the developers, they were delivering them 2 or 3 days after the developers put the code into an integrated environment where it could be tested. So how can this thing called SBE, specification by example, possibly do that thing? How can it make that big of an impact? Well, it's not a tool. It's a methodology. If we come in and introduce a new tool, we might be able to give you a 5 or 10% improvement. But to get a really big improvement, you have to change the methodology, like changing from waterfall to agile. Very fundamental change, very major benefit. And specification by example is a paradigm shift. Just as waterfall to agile was a paradigm shift, people had to learn to think in new ways. So just as waterfall to agile changed the entire process, specification by example changes your entire process. If you want to get the benefit out of it, it does. It eliminates a number of things that you think are essential. And it shortens existing processes. So let's look at some of those. Here's a typical development process. And this is a bit simplified, but somebody writes requirements. The QA team starts writing manual test cases while the developers write code. Developers deliver the code to QA and they execute those manual test cases. Then the automation team comes in and starts automating them. And in a well-run SBE process, here's the process. We're consistently delivering automated tests to the developers in sprint. That means regression tests and tests for new functionality. So the only manual tests should be for things that automation can't easily test, primarily visual verification of the UI. You know, the colors, are the colors correct? Does it fit properly on all of the cell phones that we want to support? Are the visual elements positioned properly? Those are pretty easy for people to verify and very challenging for software to verify. Then let's look at the defect life cycle. Well, here's again a simplified defect life cycle. We write requirements, we write code, we merge the code with the main branch, we deliver it to QA and run tests, we write defects. The developers look at those defects and go, oh, no, that's not a bug. We intended it to do that. And then there's an argument with the product owner of whether or not it's really a bug. And you know, and then you may have lots of other statuses for the bug. Is it deferred? Is it going to get fixed in this sprint? Is it, you know, this is a simplified diagram. And eventually, after you go around this loop a bunch of times, the code gets delivered after all the bugs are fixed, or more realistically, after the developers announce that they are just about to lose the will to live. And the product owner decides, rather than accepting the death of the entire development team, I'm going to accept some bugs, and we will deliver it to production with some bugs and fix them later. And here's the SBE defect life cycle. There is no defect life cycle. A team using SBE doesn't need a defect life cycle. The developers are running all the tests and regression tests and tests for new functionality on their own, you know, every build on their own systems. And if one of the tests fails, the developers, they just fix it right there. So at United Technologies, the data science teams I was working with, we modified the process. They didn't even open a pull request until all of the tests passed. So there were no bugs being delivered to QA, much less to production. So what's the value in tracking a defect that never gets to the QA team, that has a life expectancy, a maximum life expectancy of a few hours? You don't need a defect life cycle. Here's a typical document flow. A typical development project requires a number of documents. You've got the requirements documents, and then you've got the architectural design documents, schema for the database and how you're going to split this between servers and, you know, the major packages that you're going to use to implement things. And then you need functional design documents that include additional boundary conditions that were not listed in the original requirements documents, because the developers have to code for all of the boundary conditions. And then you have test cases, which are written from the requirements documents. And then you need a requirements traceability matrix to show you, when you execute those test cases, which requirements now have passed and which ones are still failing. And every time you create one of these new documents, the functional design documents, the test cases that include additional boundary conditions, you're creating an opportunity for one of those teams to have a different understanding of what it is they're supposed to be delivering. And you don't want that. And that's an opportunity for the developers to write really high quality code that does the wrong thing. That big B bug that looked so hairy and You didn't want to get near it. The test cases are almost certainly never going to be reviewed by the product owner, nor by the developers. So the testers could have a third viewpoint on what's going to be delivered. And all of these documents are decoupled. If the requirements change, you have to go track down which of the architectural documents, which of the functional design documents, which of the test cases have to change and how they have to change. And that's all manual, and it often never happens. Here is an SBE document flow. There are only two documents. You've got requirements documents and you've got architectural design documents. You don't need functional design documents that list additional boundary conditions because as we're going to see, the requirements documents are going to list all of the boundary conditions. And we don't need any test cases because the requirements are identically the test cases. And that doesn't mean the requirements tell us what to test. It means the requirements are literally the automated test cases. We automate the requirements directly so that we can run them. We create an interpreter that can interpret our requirements and run them against our implementation, just like a Python interpreter runs a Python program. So our requirements are executable. They can run themselves against our system and they can tell us which requirements pass and which requirements fail. So why would you write test cases if you can run your requirements? There's no need to. And why do you need a requirements traceability matrix? If you run your requirements, your report is a list of the requirements, and every requirement is either green or it's red. And that's not too difficult to hand that to the product owner and go, here's where we are. The product owner looks through and goes, oh, no, this one's red. I can't allow that to go to production. There's no interpretation there that the product owner can look at this and go, yeah, I get exactly what's not working. May not understand the details of why, but knows what the impact is going to be on the customer. So specification by example is not a QA tool. It is a radically different development methodology all the way from requirements to delivered code, and it is a radical paradigm shift. Just as waterfall to agile was a radical paradigm shift, and those people who adopted the trappings of agile without adopting the methodology, without making the mental shift, were the ones that I heard about at one company where their agile project just, it didn't do anything for them. They were just, the VP of engineering was completely unimpressed with agile. He said, the only thing I've ever seen agile do is make a project 6 months late. And they were clearly agile. They had a scrum and they had 3-month sprints. And I heard 3-month sprints. I don't think that's agile. So specification by example is a paradigm shift. If you approach it as a tool, you are unlikely to get good results. When I introduced specification by example at Raytheon, some of the developers were strenuously opposed and lobbied my manager to get rid of me. They did not want this. This was not helping. It was too hard. And once we started delivering automated tests in Sprint, their attitudes changed. They were like, dang, I'm not going to deliver any bugs. And one of those developers is now my biggest supporter. So how does this actually work? Well, a traditional narrative requirement might include a user story like this. As the accounting department, I want to charge people penalties for late payments. Anything over, we're going to be cruel, 14 days. Anything over that, we charge a penalty. That same requirement written using specification by example might look like this. Given an active customer account, We have to have an active customer account in order to have a past due bill, and a bill that is 15 days past due. When the bill is paid, then a 5% penalty will be charged. And the developer reads this as when the bill is paid. That's the action. This event happens and comes to my software, and my software has to process it and manage it. The first thing I have to do is test the preconditions. The preconditions are an active customer account and a bill that is 15 days past due. If those things are true, then I, the developer, must create the desired result. And the desired result is then a 5% penalty will be charged. Writing requirements with concrete examples like this, 15 days is concrete, 5% is concrete. There's no ambiguity there. It naturally leads us to ask a couple of questions. Are there other important examples that produce different outcomes? Well, yeah, if it's 14 days past due, it's a 0% penalty. And then someone's sure to ask, well, are there any longer periods? Do we go up to a higher penalty rate at some later point of time? So putting in concrete examples causes these conversations to happen. So you're drawing out all of the boundary conditions up front early. And then you also ask, are there different contexts, different preconditions, which would produce a different outcome from the same event? Suppose the account is suspended rather than active. Will the penalty be different? Suppose we have new accounts that have never made a purchase. Are we going to charge them a penalty on the first purchase? Lots of good, useful questions. So specification by example says that we must show all of the important examples. And to a QA person, this is just second nature. You always think about these boundary conditions when you're writing test cases. Different contexts, different preconditions, different penalties for different days past due. So how does this help? Well, the product owner benefits because the requirements are much clearer. So the product owner has much higher confidence that the delivered code will do what they wanted to, no big B bugs. It helps the developers because the requirements list the boundary conditions, concrete examples, and the boundary conditions are exactly what the developers must code. There has to be an if or a case statement. There's a line of code in there for every single boundary condition. And it helps the testers because all the boundary conditions are listed. And that's exactly what the testers have to test. It helps the business analysts because working with concrete examples helps everyone think of additional examples. As we've said, can this same action with different preconditions produce a different outcome? People will think about that. Given these preconditions, are there different events that could produce the same outcome? People think of examples or ask questions of the product owner. What do you want really to happen then? And I've seen it so many times where the product owner says, oh, I hadn't thought about that. Here's what I want. And you write the requirement. It does not reduce the business analyst's upfront work. But it does absolutely reduce the questions after the requirements are delivered. At GM, after the business analysts switched to specification by example, they told me that it didn't save them any work up front. And in fact, it might be a little bit more work. But once the requirements were delivered, There weren't any more questions. No phone calls, no emails, no instant messages, no one coming by their desk or stopping them in the hallway and asking, what does this requirement mean? And they said that they would never go back to writing narrative requirements. And it absolutely eliminates having the same question asked multiple times by multiple people. The developers ask it, and then the QA people ask it, and then if you're a business analyst, you've certainly seen that. So how do we actually write requirements using specification by example? Well, specification by example says that we must write requirements in a given, when, then format. Given these preconditions, when this event happens, then this is the expected result. And that given, when, then format is called Gherkin. And there's an amusing story behind that. The first popular tool for automating testing of requirements written this way was called Cucumber. And the amusing story is how it got its name of Cucumber. And then, of course, the language, the given, when, then, they just stuck with the Cucumber theme. So the way we write requirements, we write a business rule from a user story. So a business rule might be bills more than 14 days late will be charged a 5% penalty. Or it might be late bills will be charged a penalty on a sliding scale. And then we illustrate that business rule with the Gherkin. And then we illustrate the Gherkin with concrete examples. So here, for example, business rule, bills more than 14 days late will be charged a 5% penalty. And so we write scenario. That is a requirement written using the specification by example methodology and written to be automated by any of the several tools that are available depending on your language of choice. And then we write the Gherkin, given an active customer account and a bill that is 15 days past due. When the bill is paid, then a 5% penalty will be charged. So we write the business rule, we illustrate the business rule with the Gherkin, and we illustrate the Gherkin with concrete examples. And then a little bit more complicated, suppose we have more than one penalty amount. We have penalties on a sliding scale depending on how late the bill is. So we write scenario outline. A scenario outline is a sketch of a scenario. It is incomplete until we see all of the examples. A single scenario outline is equivalent to multiple scenarios, one scenario for every line in the examples table. So let's look at that. Given an active customer account and a bill that is this thing in angle brackets, days past due. When the bill is paid, then and again, this parameter in angle brackets, this penalty will be charged. And then we have an examples table that shows values, concrete examples for those parameters. So the concrete examples are that we look down and we see this examples table, we find days past due as a column heading. And so this scenario outline, when our tool of choice, Cucumber, SpecFlow, Behave, whatever you're using, when it evaluates this requirement, the first time through, it says, and a bill that is, and it looks down in the first row and plugs in 14 days past due. When the bill is paid, then A, and it looks down again in the first row, finds the penalty column and plugs in, then a 0% penalty will be charged. And then it does it again, 15 days, 5%. And then again, 29 days, still 5%. And then 30 days, 7%. So our requirement clearly illustrates all of the boundary conditions. And if we missed one, someone is sure to ask, don't we have a higher penalty after 90 days? And the product owner will go, oh, yeah, I'd forgotten that. And you put it in. So the goals of specification by example, excuse me, just a second. The goals of specification by example. First, to assure that everybody, all the stakeholders, all of the team members have the same understanding of what needs to be delivered. Do not write big B bugs. Because specification by example tells us to write the requirements together, product owner, business analyst, developer, and QA, we have a much better chance of everyone understanding what needs to be delivered. Second goal, provide precise specifications. So we avoid rework, no little b bugs. The requirements are more precise because we have to use concrete examples. And if we also very carefully define the terms that we're going to use and use very clean, consistent, and sparse gherkin, don't put in extra words that you don't need, then our requirements are going to be even more precise and easy to understand. And that's going to help prevent the developers from writing the wrong thing. Provide an objective definition of done. Well, since our requirements are executable, they can tell us when they're done. When they're all green, they're done. Automate testing without changing the specifications. Well, our requirements are identically our test cases. We didn't have to translate the requirements into something else in order to automate them. So automate testing without changing the specifications. Provide reliable documentation. Well, our requirements can test themselves, so they are reliable documentation. If they're wrong, they tell us they're wrong. We no longer have documentation where we are unsure which parts are right and which are wrong. I know you have been brought into many projects where they give you access to documentation and they say, oh, here's the documentation. Now, most of chapter 4 is correct, but there's some parts that aren't. And chapter 5, that's mostly changed. And you're going mostly. Well, which parts are mostly? And you don't know. You can't have that here because the requirements tell you which parts are right and which are wrong. Hopefully you change the requirements before you change the code, but if it didn't happen that way, at least you know what's wrong. And finally, minimize the cost of maintaining your documentation. Well, again, the requirements can test themselves. So there's not a lot of cost in maintaining the documentation. All right, now how do we automate testing in this methodology? Well, there's some additional goals, making test automation much easier so we can deliver in sprint, and dramatically reducing the maintenance cost for our test automation, and reducing manual testing to primarily visual verifications. If you can deliver in sprint, then you don't need to do lots of manual testing. Oops, sorry. Again, going back to General Motors, we reduced the cost of maintaining, updating, and running the automated tests by about 80%. And that 80% savings doesn't count the reduced effort by the manual QA team, they had a lot less to test. We could meet with them as soon as the requirements were written and divide the requirements into 3 parts. Part number 1, these will be automated by the time you get the code. Do not write manual test cases for them. Don't worry about them. They'll be there. Part number 2, we're not sure about these. We're going to try to automate them, but they're a little tricky to automate. It's going to take longer. We may not get to all of them. Put those at the bottom of your list. And if we don't have them automated, then you'll need to write test cases. And the third group, these are not going to be automated. Verifying that the map looks correct or that the pin on the map is in the right place. Easy for a human, really challenging for software. So plan to test those manually. So we saved them a lot of work and they loved us. How does it do that? How do we make test automation so much more efficient? I've worked on lots of test automation projects, and I've never seen one that was a technical failure. They all delivered some kind of automation at the end of the day, but I've seen an awful lot of them that were business failures. The automation that they delivered was so fragile that it didn't deliver a lot of value. Well, the way that SBE does this is abstraction. Here's that requirement. In Programming 101, our professors taught us to make the upper layers of our programs as abstract as possible and to push all of the implementation details as far down as possible, because that's going to reduce our code maintenance cost. And specification by example teaches us to write requirements that are very abstract with all of the implementation details pushed as far down as possible. So that's exactly what our professors told us to do because it would reduce maintenance costs. Look at this requirement. There are no implementation details in this requirement. In a typical test case, there would absolutely be a customer account number, quite possibly customer name, address, billing information, who knows what all. Here, those details are pushed way down into the underlying code. The product owner doesn't care about the account number. The account number is irrelevant to when and how much penalty gets charged. Also, a product owner can read this requirement. If it's cluttered full of implementation details, the product owner may not understand what it is you're trying to test. Abstraction allows us to reuse Gherkin. So we have scenario, given an active customer account, and then we write a piece of code called a step definition to automate that. Well, then if we write given an inactive customer account, we can reuse that same step definition. Or given an expired customer account or any other kind of customer account that you have, how many different types do you have? You reuse the step definition. There's no code to write. You write it once, it handles all of them. If we do our job well, we might have 1,000 requirements and maybe only 150 unique given statements. All of the rest just get reused. And when you reuse it, there's no code to write. It's already automated. Same thing for the when. When the bill is paid, write another requirement. When the bill is paid, write another requirement. When the bill is paid, they can all use that step definition. Again, for 1,000 requirements, if we do it well, we might have only 150 unique whens. And same thing for the thens. Then a penalty will be charged. We write bunches of requirements and they all have penalties and they all reuse the same code. And then we have helper methods underneath those step definitions. And we write a new step definition and they reuse helper methods and so on down. So if we write good Gherkin, we get a lot of reuse out of it. Specification by example doesn't force us to write clean code. It does strongly encourage it. And if we do that, we can easily retarget our automation at a different interface while reusing lots of code. So different interface, I mean API, switch to testing the website, reuse a whole bunch of code because your implementation details are pushed down. There are no button names or field names in the requirements. At Raytheon, the developers switched from a REST API to a GraphQL API, 100% change. And we had hundreds of requirements already written and automated. And the developers kept telling us, you're gonna have to start over. You're gonna have to rewrite all of your code. And we kept looking at them going, no, don't think so. Why would we have to rewrite all our code? And when they finally delivered it to us, we had to rewrite some low-level helper methods. And we had all of the automation, hundreds of requirements up and running again with about 1 developer week of work. So if we'd written our automation the old way with the REST payloads in the top level, complete rewrite. Doesn't force you to do it this way, encourages you strongly to do it this way. So reuse. So we can save $50,000 per developer per year. It's been documented to almost completely eliminate bugs. And if we implement it well, we can save $50,000 per developer per year. And that doesn't even count the value of delivering correct code sooner. A lot of value in that too, and happy customers. So how much of that do you want? And if you want to learn more, there's some recommendations here, and we're open for questions.
Hey, Leslie, it's Sue again. Yep. You're over. I tried to ping you, but my bad.
Oh, sorry.
No, you're good. I did not see any questions in the chat. I just nudged a little. I know we've got about 15 minutes before the next speaker on the other channel, but I know that at least one person reached out to me and truly enjoyed it.
Oh, good.
And I will say that we are also fixing the fact that you are not in the drop down on the survey. So I was going to nudge people to fill out the survey, but unfortunately we need to fix that and get your name on there. So I hope everyone will, I've passed that up.
Okay.
But it is unavailable at this time. So looks like we've got a couple messages. Hold on, let's see. We got a couple of thank yous.
Good.
I don't see any questions, but you should definitely look at the chat for your kudos, and I'll give you kudos. Thank you.
All righty.
Thank you for stepping in at the last minute. We appreciate that.